Thank you, Mary. So one of the questions we get is that why would we need a parametric environment to generate anything related to paneling, for example, and you know, like I showed with the history option, that you can use some parametric using Rhino, but you are limited with the history and its limitations and the number of operations or the number of things you can do or control parametrically. And this is why using an environment like a Grasshopper, where it's actually give you a full control over how your parameters are defined and controlled. So let me just hide that for a second. So suppose you have some kind of a free-form surface that you want to populate a pattern on top. In this case, I'll just, you'll see that I created a number of parameters, which is a number of divide points on this surface that I can drag at will and change that number. Number of divide and the V direction. The density is changing, and I'm looking at it as it changes. I created some attraction that goes from one direction to the other for my panels. I also have control over the number of segments of my modules, so I'm just creating a gradual transition here from the bottom left corner of my hexagonal or four-sided hexagonal up to a 19, or it almost looks like a circle kind of hexagon, and gradually kind of change that module based on my attraction. So that kind of effect sometimes it's pretty kind of hard to create if you are working with an Rhino environment, and I'm just going to hide that to kind of just give you an idea of how that shape is looking. But it's pretty easy and straightforward to create using Grasshopper environment. Let's create that from scratch. I'm just going to hide everything just to show you that this is really not very difficult to use using or generate using a Grasshopper environment. The first thing you should notice here is that once you have installed paneling tools for Rhino, a new tab gets added to Grasshopper called Paneling Tools. This is the Grasshopper environment up to here. And then you click on Paneling Tools tab, and it has all the different functions that, dividing curves, different ways of generating grids. That's one way is to generate a grid by a surface domain number. In this case, you can select the command and drag it into the canvas. You can generate attractions using point attractors, curvature, all the things we saw in the paneling tools for Rhino environment is here. There is a grid utility functions. There is the different routines to panel with 2D, with flat grids or thin grids, if you will, and the 3D as well. There is some panel utility here to pull some edges to the surfaces. And also some ways, like if you generate your grid in Grasshopper, you can bake it to the Rhino environment, and it will have all the naming convention, and you can work with it within Rhino. Or if you have generated your grid in Rhino and you just simply want to select it from there, you could. So let me show you, for example, if I wanted to generate a grid with varying the number of divide in the U and V direction. I have my surface here. So I feed it into my surface component. By default, it divided by 10 by 10. But I can feed my own numbers. Once I do that, I'm able to change my density as I drag the number of divide points here, right? So once this is generated, now this is my grid basically. So that's the grid that I have just generated. And that was my input surface. See, if I select it, it highlights with the green in the Rhino environment. This is the number of segments in the U direction and number of segments in the V direction. If I just want to create some cells or panels out of it, rectangular, I can use that cellulate option. I'm going to hide my surface so you can see. That cellulate option created all the cells for me. But if I instead wanted to kind of drag my grid or make it attract to one end or another, then I can use the grid attraction routine, or if this is a point attraction. And I can feed it my grid, right, with the attraction point that I can generate. So just break that. And let me just create a point in the Rhino environment that I will reference to use here for attraction. So I'm going to get the point parameter and set one point to be that my corner point. And if you look at the grid now, you'll see how it got attracted down a little bit compared to the original one. So if I just feed my paneling right there, you'll see how it's not showing as clearly, but I can change the magnitude of how much I want to enlarge that change. And you'll see how that is starting to look when you start pulling it to the extreme, one extreme or the other, attracting away from my point. And look what's happening now. So I'm almost having like a living organism that I'm just actually being able to kind of change to what I want it to be looking like. And if I had some kind of a module that I wanted to gradually populate in between the grid points, then I can generate these modules. And the Grasshopper environment, you can create a polygon with any number of segments. So I'm creating 2 polygons here. One of them is with 4 segments, feeding it into the right input, which is the number of segments, and another one with 17 segments. And as I mentioned, all the routines, or most of them that are available in the Rhino side for paneling tools, are available within the Grasshopper environment. And one of them is to morph 2D mean, which is basically gradually move from one module to the next using your attraction. And that's the kind of function that I'm looking for basically paneling gradually, or variable mean paneling. What it takes is your grid, and it also takes the weights, which are how much you know, are gonna the map of the degree of attraction here. And some starting, I'm feeding now the starting and the ending module. And you see how that got populated there. I'm going to delete that. And now that my module is created here on that, populated on that surface, I can go back and change, for example, the density of my grid. I can change the magnitude where the degree of attraction to one end or the other, right? I can start changing the number of segments that I'm dragging from one end to the other. And that will give me a truly parametric or modular kind of design that helps me explore a wide range of concepts, and that's what's really mainly used for. And actually, yeah, so on that note, that's actually all the things I wanted to cover in this webinar, and I really thank you for sticking with us. It took a bit longer than it was planned, but hopefully it's been useful to just kickstart your work with paneling tools and be a productive experience